All right, so you've made it to the final set of learning objectives, and based on the numbering, you can see we're going to go back to talking about solving equations. All right, so you've kind of visited this twice before, the initial case, then we used identities, and now we're going to figure out kind of a final way that we can solve equations using sine and cosine. All right, so recall that a quadratic equation, all right, so we're going to use some stuff we learned in the fall, has this x squared in it, and our general form is ax squared plus bx plus c. And we had two main ways we could solve these ones. We could solve them by factoring, so breaking this up into two separate factors, or by using the quadratic formula. For pretty much this whole video and all the practice, you'll be able to factor it. So that's the main one I'm going to focus on in the video, because it'll be more useful. Let's say I want to solve this equation. 2 sine squared x minus 5 sine of x plus 3 equals 0. This seems pretty complicated because we have sine squared in the equation and we have a sine in the equation. We can't replace the sine squared because that turns into cosine squared and makes it even more complicated because then I have two different expressions. But this is called, this whole learning objective is equations of quadratic type. So they're not quadratic equations exactly, but they follow the same pattern of quadratic. So a quadratic equation has this form. And you see there's something squared, that same thing not squared, and then just a constant term. That's exactly what we have in this situation. We have sine being squared, sine not being squared, and then no sine. So similar to when we were doing the multiple angles, we had that b in the parentheses. What we can do is substitute for that trig function. A little bit bigger substitution than we did before, but this is going to turn this equation into, instead of sine squared, I'm going to get u squared. Instead of sine, I just get u. And this right here is just our normal quadratic function. We just have 2x squared minus 5x plus 3. We can solve this using our methods of solving quadratics. All right, so I'm going to do it on the left-hand side so we have some room to finish the problem at the end. I bet. Again, at this point, it's your quadratic equal to 0. If you want to, you can just use your quadratic formula. All right, I'm going to factor it just as for multiple reasons. I want to kind of remind you of the process of factoring, but also I think it's a little bit better when you get down to those answers at the end. All right, but if we want to factor this, we need to find two numbers that, oops, I don't want to use a and c. I want to use two numbers that add together to give -5, and then multiply to give 2 times 3 is 6. So there are two numbers that multiply to 6 and add together to give -5. It's going to be -2 and -3. And if you remember from a long time ago when we were talking about quadratics, if that number 2, there's a number in front of the square term, I can't just go directly to the answer. I do this weird thing of splitting up that middle term into two separate terms. And then I do it as two groups of 2. So this first group of 2 I can factor out of 2u. The second group I can factor out of -3. And now I have this u minus 1 that's repeated that I can pull out. And why do we factor? Why do we get this stuff factored equal to 0? Because if things are factored and equal to 0, I can have u minus 1 equals 0. In that case, it doesn't matter what 2u minus 3 is. My answer will be 0. And I can have 2u minus 3 equals 0. Again, it doesn't matter what u minus 1 is going to be because I'm multiplying. And I get u equals 1. And u equals, well, let's do it in 2 steps. 2 equals 3, u equals 3 halves. So this whole right-hand side of this slide is solving the quadratic equation with our variable u. Again, you don't have to use u. I just use u a lot because there's something in calculus called u substitution, so I'm used to it. You can use whatever letter you want, pretty much other than x, because that's our original variable. But we solve this quadratic. We know u is 1 and u is 3 halves. But remember that u is actually sine, so we actually get sine of x equals 1, and sine of x equals 3 halves. Sine of x equals 1. If you remember back to our previous learning objective, sine is the y value, and the y value is 1 at the very top of the circle, which is pi over 2. And again, remember, we get those kind of repetitive answers when we get plus 2 pi k. when is sine of x equal to 3/2? Well, 3/2 is 1.5, and the biggest sine ever is 1, so it's never going to be 1.5, so that has no solution. So our final answer is just this part there. All right, so you can see why this kind of topic is in that third set of learning objectives. It's really pushing you to remember things from the past and all the stuff from earlier in this unit. You have to know to do this kind of substitution, which is something we've done before. You have to remember how to do a quadratic equation, which is something we haven't done in a while. We did that in the fall. And then you have to remember our earlier learning objective, how do you solve equations that look like that? All right, so we're putting a lot of different things together that we've learned in order to solve this equation. Right, and here's one for you to try on your own. Just one hint, there's no number here, which means your factoring step is going to be a little bit easier. You don't have to go through all those steps to factor. All right, but go ahead and try to solve this one. And in the end, you should come up with something that looks like this. So first thing, we have this quadratic type pattern. So we make u sine of x. All right, it's going to turn into u squared minus 4u minus 5. Again, because there's no number in front of u squared. Once I have that pair that add to -4 and multiply to -5, I can just put them directly in my factored form. And that tells me that u is either 5 or u is -1. All right, so this left-hand side, again, is just solving that quadratic that I get when I replace the sine with u. And remember, u is actually a placeholder for sine. So sine is 5. That's never going to happen because the biggest sine ever gets is 1. Sine is -1. All right, the y value -1 happens at the very bottom of the circle. 3 pi over 2 in radians, again, plus 2 pi k. And then combining even more stuff that we've done previously, all right, can we use our identities to simplify first and then turn it into something of quadratic type? All right, so how's that going to happen? Well, cosine of 2x. There's 3 different formulas for cosine of 2x. We have sine squared minus cosine squared. No, cosine squared minus sine squared is 1. We have 1 minus 2 sine squared and cosine squared minus 1. All right, so if you look at your double angle identities, you have 3 different choices. But since we're in quadratic type, we want to choose something that has a square in it. And I want to choose this one. All right, why am I going to choose this one? Because I have a normal cosine over here. If I want it to be a quadratic type, I also need the cosine squared. If I move this over to cosine squared of x minus cosine of x minus 1 equals 0. All right, so now by using an identity, using the correct identity for cosine of 2x, I turn this into quadratic type again because I have a squared, non-squared, and a constant term. So now it's just like our previous examples. We're going to make u our trig function. It's going to turn this equation into 2u squared minus u minus 1. So when we go to factor this, we're looking for 2 numbers that add together to give -1 and multiply together to give -2. And that's going to be -2 and +1. So now I rewrite my equation. Factor out a 2u from the first 2. I don't have to factor out anything, so 1 from the second 2. And I pull out that u minus 1. And the whole reason we do this is because if u minus 1 is equal to 0, u is 1. If 2u plus 1 is equal to 0, 2u is -1, which means u is -1/2. But then we go back and remember, we weren't using u, we're using cosine. So cosine of x is 1, or cosine of x is -1/2. Cosine of x is 1 only on the far right of the circle, so that's when we get 0, plus 2 pi k. The cosine is -1/2 in quadrants 2 and 3. And cosine is 1/2 at pi over 3. So if I put all that together, I'm going to get 2 pi over 3 is that angle in the second quadrant. And the angle in the third quadrant when cosine is negative is going to be 4 pi over 3. But again, I did that kind of right-hand side kind of quickly because it was a previous learning objective. All right, so if you need to remember how to do cosine of x equals to negative 1/2, you can go back to that learning objective. All right, we can see we get a lot of answers. All right, these three pieces together all make up the solutions to that original equation. All right, so adding together pretty much all we've done with solving trig equations. All right, we have to know how to solve the original ones. We have to know how to use identities to simplify things. And then the big thing is kind of remembering how to solve quadratic equations from earlier in the year. All right, one more for you to try. All right, this one's already kind of set up for you. All right, change it into a quadratic and solve. All right, in the end, you end up with something like this. So again, making u cosine of x turns it into this quadratic here. This one's actually a little bit simpler because you don't have to do the full quadratic factoring. I can just pull out this common u out to the front. And u times 2u plus 1. U is 0. If 2u plus 1 equals 0, you're going to get u as negative 1/2. Then we switch and replace the u's with cosines. Cosine is 0 at the top and bottom of the circle. And this one just happens to be the one we did in the previous example. All right, cosine is negative 1/2 at those two angles. Again, they all have plus 2 pi k, which gives us our full answer there. All right, so if you're multiple choice, which of these equations is not of quadratic type? So think about what it means to be of quadratic type. Which one doesn't fit that description?